Okay, welcome to section 8.2. Today we're going to be talking about solving systems of equations by substitution. Now, the idea behind this is going to be to really look at having two equations and making it or simplifying it down to just being one equation. So we are going to that should be turn two equations into one equation to solve for one variable and then use that one variable to solve for the other. And really the main idea is that once you know one of the variables, you can really easily figure out what the other one is. So we're going to look at a few problems, and then we're going to actually take a look at what the real steps behind using substitution are. So the first one here, I have 4x plus 6y equals negative 24, and I have x equals 3. Well, I just about guarantee you that the point where these two lines intersect will be at 3. Let's in fact go ahead and, we worked on this last unit or last section of actually graphing these. Let's go ahead and graph this and see what we get. So 1, 2, 3, 4, 5, 6. Went back 6 because I look at my x-intercept on this first one as 4x equals negative 24. When I divide by 4, I'm going to end up with x equals negative 6. So the x-coordinate is negative 6. The y-coordinate will be negative 4. 1, 2, 3, 4. And so I can go ahead and graph that first line. Try to get a decent job on here because I'm not really working on a graph. I'm just kind of freehanding this one to get an idea. And that's way too high. Let's go ahead and knock that down a little bit. Okay, but that'll give us some sort of idea as to where these two lines are going to meet. The other line is x equals 3. Well, where does x equal 3? This vertical line right here. As vertical or non-vertical as that is, okay, my point of intersection is going to be down here somewhere. So it should have an x-coordinate of 3. And what would the y-coordinate be? I don't really know, and especially on my graph where, number one, who knows if these units are even. Who knows if these units are even, and I totally missed that line there. So, I know it's going to be a negative something, but I don't really know what it is, okay? But my point of intersection will be 3 and then negative something. Well, let's see what y is when we plug 3 in for x. So we have 4 times 3 plus 6y equals negative 24. So I've just plugged that 3 in for that x right there. And let's see what I get. 12 plus 6y equals negative 24. I'm going to subtract 12 from both sides. That'll be negative 36. Divide by 6, and y is going to be negative 6. I can believe that because that's negative 4 right there, and I'm down even farther from that. So I would say that's a pretty good guess at 3, negative 6. So my answer here is 3, negative 6. Okay. Now, I understand we kind of graphed it here, but we also use substitution for this problem. There weren't a lot of steps to follow in order to use substitution. But the idea of substitution is that whenever you know what a variable is, that variable is always going to be equal to that value. Let's look at this next one. Okay, I have y equals on both of these, so they're both in slope-intercept form. Well, I know that in this system, for these two lines to meet, that y has to equal y. Well, that also means that negative 2x minus 4 equals 4x plus 14. So if you notice here, now I don't have any y's, I just have an x. I have two x's, okay, but I can figure out what x is now. This is just an equation with the variables on both sides. So I have negative 4 equals 6x plus 14. And then I would subtract 14, and we're going to get, that'll be a negative 18 equals 6x. So x is going to be negative 3. Well, now that I know what x is, I can use that, just like I did in this first one, to solve for y. I'm going to do that in a different color. So let's use either equation. It doesn't matter. I'm going to pick the bottom one because there's no negatives. I don't like negatives. So y equals 4 times negative 3 plus 14. So we know that y equals, that's going to be a negative 12 plus 14. So y is 2. So my answer here, and remember I'm always going to answer in the form of a ordered pair or a point. My answer is going to be the x-coordinate and then the y-coordinate. And that'll be my answer. The beauty is we don't have to check it because we've used algebra already to figure out our answer. And also this is a great method for, those pesky problems where we were dealing with fractions and, trying to guess where it's going to be. This makes it really nice. Let's look at this one over here. So in this one we have a situation where we know what one variable equals. We know that y equals negative 3x plus or minus 18. I'm going to plug that in for the y up here. Okay, kind of hard to see because there's not a lot of room, but I'm going to replace this y with what y equals. Okay, so we have 5x minus, I'm going to put the whole thing in parentheses, negative 3x minus 18. And then I have the minus 20 equals minus 22 over here. So my basis here is I'm using the top equation with the added thing of not having the y, having what y equals. So we have 5x. I'm going to distribute that negative. Just change the sign of those ones. Plus 3x plus 18 equals negative 22. Okay. It's looking like the numbers are going to get a little bit bigger here. We have 8x plus 18 equals negative 22. Subtract 18 from both sides. This is just solving equation stuff. We've done that before. And 8x equals negative 40. And then we divide by 8. And x equals negative 5. Okay, so I have my x value. Now I'm going to find my y value by using that. Okay, so what I'm going to do is plug in that negative 5 into one of the equations. Now, there is an easy one to use. I could use either one of them, but this one says y equals, so that means I'm not going to have to move anything across the equal sign. I'm just going to evaluate, which is a lot easier. So I'm going to take that negative 3 and multiply it by negative 5. I'm replacing the x with negative 5 because I know that's what x equals. And then minus 18. So negative 3 times negative 5 will be a positive 15 minus 18. So y will be equal to negative 3. So my answer for this problem is the x is negative 5 and the y is negative 3. Not too bad. All right. Now, some people kind of like to, obviously I do, but like to follow a certain step-by-step process. And if you like to do that, you can. If you just like to kind of think it out, you can do that also. But the main steps here are solve one equation for one variable. We've had that done in the problems up above. Substitute the expression from step 1 into the other equation. That's this step right here. So this right here is our step 2. Okay, where we put this expression in for this y. Okay. And then and solve that equation. Okay, solve for the other variable. And then plug that and plug whatever you find in, plug that 5 in for an x in a variable, and then you can check them, but there's not a lot of checking that needs to be done because we've used algebra, and we're not really guessing here. So here's the question: is substitution or graphing easier? And my easy answer is that it really kind of comes down to what does the problem look like. In this one, I'd say either way isn't too bad. But let's go ahead and use substitution first. I want to solve this equation for, let's solve it for x. So sometimes I'll put a little note here that I'm solving for x. Just underline that. So I'll subtract the y over, and I'm actually going to write it as x equals 5 minus y. And that way I don't have to have a negative y, and remember that y is negative. Just makes it easier sometimes. Now I'm going to substitute this part in for x down here. Okay, here's what that'll look like. So I have negative 5, and I'm going to keep that in blue. Okay, minus 7y equals negative 21. What I need to do here now is to distribute. So I'll have negative 25, that'll be a plus 5y, minus 7y equals negative 21. Now I can simplify this, and we'll have negative 25 minus 2y equals negative 21. Add 25. Okay, and now I have negative 2y equals, that'll be a positive 4. So y equals negative 2. Now, what I always use is I'm now always going to take that negative 2 and plug it into my altered equation. You don't have to. You really have 3 equations to pick from. You could use this one, or this one. Okay, I usually try to find the easiest, and this one's actually the easiest because it's already solved for x. So x equals 5 minus, and I will usually put that in parentheses, just because it's another negative in the problem. But when I go 5 minus negative 2, that's like saying 5 plus 2, or 7. So my answer here is going to be, what do we have here? We have 7, negative 2. Okay. Let's go ahead and graph that and see if that makes sense. So for my first one, if I use the cover-up method, okay, I can cover up the y. It gives me x equals 5. If I cover up the x, it tells me y equals 5. And I can graph that line. Try to get a good graph on here. And then I can graph the other one as well. And I'll use the cover-up method. It's not great here, but let's make sure we can see that. So negative 5x equals negative 21. So that would mean that if I divide 21 by 5, I'll get 4.2. Just going to check it on a calculator. So negative 21 divided by negative 5. Yeah, 4.2. It's kind of tough to see because of the light, but we do get 4.2 for an x-intercept. That'll be about there. And then for this one, when we cover up the x, we get negative 7y equals negative 21, which gives us a y-intercept of 3. So when we graph those, and so this is why I say it's easier sometimes to use the substitution method, because my answer is over here, 7, negative 2. It doesn't quite look like they cross there, but they look like they could. So I think substitution's easier. It's always going to give you an answer, and even if it's a decimal or a fraction, okay, it definitely helps out, and it takes away the graphing aspect and the is the line straight and all those different things that can go wrong when you graph. So let's go ahead and move on and check out some more examples here, and we should get out of here pretty quick. All right, let's look at this one. So in this one I have both equations solved for y. So I'm going to take this chunk here, take this one, and put it in to that y. All right, so I have negative 4x minus 22 equals negative 3x minus 17. So when I do that, all right, when I do that, I just have one equation now and one variable. So I'm going to add 4x to both sides. Remember, it always helps to move the most negative x term. So that'll be x minus 17. And I'll add 17 to both sides. And what's that give us? X equals what? Negative 5. Okay, now I'm going to use that negative 5, and it doesn't matter which equation I plug it into. I'm going to go and use the top one. So I'm going to say that y equals negative 4, and that negative 5 comes from the other equation. Okay. And so now we have y equals negative 4 times negative 5 is 20 minus 22. So y equals negative 2. So my answer for this problem is going to be negative 5, negative 2. And it's that easy. Okay. Yeah, there's a lot of stuff to keep straight. There's a lot of steps to follow, but it's totally doable, and it's all using algebra instead of graphing and hoping that lines are straight and all that stuff. So let's look at this next one. So I have one equation solved for a variable, which is good. That's usually my step 1. But I'm going to take that and plug it in for the y down below. So I'm going to have 5x minus 5. And like I said, I always put it in parentheses, and since it's black, I'll use black here. And then that just equals 10. So the green part is the bottom equation, the black part is the expression from the equation above. I'm going to distribute here, rewrite that. Negative 5 times 2 is negative 10x. Negative 5 times 4 is positive 20, and that's going to equal 10. So combine like terms here. Negative 5x plus 20 equals 10. I'll subtract my 20s. And negative 5x equals negative 10. Divide by negative 5. This is all solving equation stuff. We should be fairly good at this stuff by now. So x equals positive 2. Now I'm going to use that positive 2 in the top equation. Okay, I'm going to use this one up here. So I have y equals 2 times the 2 from the x equation there, and minus 4. So when I'm doing that, I'm going to go 2 times 2. So y equals 4 minus 4. And that means that y equals 0. Okay, so my final answer on this one is going to be x equals 2, y equals 0. And I'm always putting my answers in the form of an ordered pair, because as you remember, the solution is the point where the two lines intersect. Okay, let's see this next one here. Let's go ahead and plug this y expression in for the y up above. All right, so the red will be the top equation, And here I'm going to put in black the expression here. We have x minus 7. And that's going to be equal to 21. Hoping that the color coding is helping you out a little bit. And if you had to do that, you definitely could. Just find some colored pencils or pens, and life goes pretty well. So negative 3 times x is negative 3x. Negative 3 times negative 7 is positive 21. And that equals 21. So when I simplify this, I have x plus 21 equals 21. And subtract 21 from both sides. X is going to be equal to 0. So now I'm going to use that x equals 0 in the bottom equation here. So y equals, use that 0. And again, I like to put it in parentheses. I don't know why. Just one of those things I always do, because if I have a negative, I want to make sure I know that negative is from the earlier equation. But here I really just have 0 minus 7, which is negative 7. Okay, so my answer, 0, negative 7. All right. What I want you to do now is go ahead and pause the video and try the next 3. All right, welcome back. Hopefully you had a chance to get those done. For the first 2, I'm just going to go and give you the answers. I'll actually work out the last one because there's an extra step that we really haven't had to do yet. This one we get an answer of 3, negative 1. And here I already know that y is negative 8 and the x value is negative 3 when you solve that. If you need to see how I did either one of those 2, you can definitely ask me and I'll help you out with those. Okay. So if you had problems getting those 2 done, just go ahead and ask me and I'll help you. But let's get to this one here because it is a little bit tricky. I need to do step 1 that I really haven't done for any of these. Okay, I need to solve one of these equations for one of the variables. I'm going to solve the top equation for y. And the reason I chose this y is because there's no coefficient on the y, and that's kind of always the easiest way to do it. So I want to move that negative 3 to the other side by adding 3x to both sides. So I'll get y equals 3x plus 6. Okay. So now that I know an expression for y, I'm going to plug that in for the y in the second equation. So that'll give me negative 6x plus 3 times that mess, 3x plus 6, and that's going to be equal to 9. Let's see what happens when we simplify this. 6x distribute plus 9x plus 18 equals 9. Combined like terms here, we have 3x plus 18 equals 9. Subtract 18 from both sides. And divide by 3. X should be equal to negative 3. That's part of my answer. Let's find the other one. So I'm going to use this equation that I made up here because it's usually the easiest one. Now I better go back to green for that. So y equals 3 times, well, what is negative 3, or what is x? X is negative 3. And then we have that plus 6 there left over. So y equals 3 times negative 3 is negative 9 plus 6. So y equals negative 3 as well. Not a big deal. Don't worry if they equal the same thing. It's totally okay. And again, you could check it if you wanted to. But I'm pretty confident in our answers. good job today. Hopefully that made sense. Again, if you have any questions, feel free to ask me. And good luck on the practice, application, and mastery challenge. Have a good day. All right, so still looking at the top NCAA buzzer beaters, we had James Forrest from Georgia Tech taking down USC. The next one is Bryce Drew of Valparaiso taking down Ole Miss in 1998. Now the idea here, or what's going on here anyways, is Valparaiso is a 13 seed and Ole Miss is a 4 seed. They're down by 2 with 2.5 seconds. And let's go ahead and see what happens, see some magic.
By Jamie Sykes, Carter pressuring. It's to Jenkins, the Drew for the win! Good! He did it! Bryce Drew did it! Valpo has won the game! A miracle!